Crews have pumped thousands of gallons of firefighting foam and grout into the underground workings of an abandoned Preston County coal mine as they try to smother a fire burning deep inside the mountain. The DEP's Jake Glantz joins us now with the latest.
Greg, crews are making headway, but battling this fire presents many more challenges than other abandoned mine fires in the past. The view from Broken Run has changed significantly over the past 6 months. Smoke is no longer billowing out of the cracks in the ground, causing health and safety concerns for nearby residents. Today, the site is more moonscape than hardwood forest. Steel pipes carrying grout, which is a specialized type of cement that's used to seal off the fire, snake from one end of the site to the other. Heat continues to ripple out from the remaining open boreholes, and the faint smell of coal smoke still lingers over the mountain.
We're about 85% completed with the drilling and grouting phase of the project. As soon as we get finished with that phase, we'll start the earthwork activities, which basically involves some reshaping, recontouring of the topography. Basically, this area, the shape of it's like a wishbone, and it's all been contour mined. And so we're going to backfill as much as we can along the high walls to eliminate air infiltration into the underground mine workings.
That air infiltration is what caused the fire, which had likely been smoldering underground for years, to grow in size and intensity, causing a dangerous situation that required emergency action. But there was a problem.
Well, unfortunately, we didn't have any mine maps. I wish we'd had underground mine maps so we'd had some idea of what to target. So we're kind of working in the blind here. So when we set up our drilling pattern, our grid pattern, we kind of had to look back and think, okay, how wide was the average heading or mine opening back in the early 1900s? And so we basically chose a 10-foot offset. It had nothing to do with our concerns about getting penetration from the flowable fill or the grout, per se in this case. We just had to make sure we're hitting these mine workings. And it becomes even more complicated when the overburden is collapsed and you have these obstructed voids.
Getting to the fire was another part of the challenge. The preferred method, as in this underground mine fire in Whitehall, West Virginia recently, is to actually dig down to the burning coal, dig it out in thin layers, and spread it out to be quenched and cooled. But in that case, the burning coal seam was closer to the surface and the overall size of the fire was much smaller. Broken Run is different.
As the underground mine workings are burning, here in this particular site, the overburden or cover material ranges from 45 to 95 feet in thickness. And as the underground mine fire progresses and moves through the underground mine workings, the coal pillars start to fail. And so you get mechanical stresses inducing the overburden.
Those mechanical and thermal stresses cause cracks, millions of cracks that allow air to be drawn in from the surface and breathe life into the burning coal seam. Heat and pressure from the fire force some of the grout injected into the mine back out through those same cracks to the surface, where it flows like lava. Dealing with the heat, over 1,000 degrees in spots underground, is perhaps the biggest challenge with this project. Crews are attacking it with the specialized firefighting foam.
With the injection of the Class A foam, of course, it helps quench the temperatures, it helps knock them down. Another thing it does, it wets the material. So in these highly fractured areas when we pre-wet that with the foam, that allows the grout when we inject it to flow a lot better. One thing can happen with the grout as you inject it into a hot environment, the heat will drive off the moisture from the grout into what it's called flash setting. It'll set up too early. In other words, you won't get it to penetrate into those cracks and voids that you're trying to get it to penetrate into.
And heat will be a problem going forward because the ground acts as a giant insulator. It could take decades for the heat to dissipate.
So depending on the mass of the material, the depth of the material, and a lot of other characteristics of the material, it retains heat for a long time. So when you're basically trying to establish vegetation on these sites, you've got to get the temperatures down, obviously, and put enough material between you and the heat source that you can sustain the vegetation.
Once crews complete smoothing and backfilling the surface, the entire site will be covered with a 5-foot thick cap of clay soil to finish sealing all the cracks and providing a buffer for plantings. The goal is to contain the fire by starving it of oxygen, to encapsulate it so it doesn't create any more problems on the surface.
For Environment Matters, I'm Jake Glantz.
Thanks, Jake. The DEP's Office of Abandoned Mine Lands and Reclamation says it would take roughly $1 billion to take care of all the underground fires burning in West Virginia, and those are just the ones they know about.